When I have a reaction that either uses or produces gases, such as the one here where the ammonium bisulfide decomposes to form ammonia gas and H2S gas, the overall position of equilibrium will be affected by the total pressure that under which this reaction is run. So let's see how that works. So this reaction, if we visualize it, the equilibrium system in a molecular viewpoint, we've got solid NH4HS down here, and there are some gaseous ammonium and gaseous H2S molecules above that solid. The equilibrium constant for this reaction can be written in terms of the concentration or the pressure of ammonium and the pressure of H2S. And the ammonium bisulfate does not need to be included in our equilibrium constant because it's a pure solid and its activity is equal to 1. So the equilibrium constant in terms of concentrations is the ammonia concentration times the H2S concentration. So if I'm at a total pressure where this system is in equilibrium, then the pressure of H2S and the pressure of NH3 above this solution will combine to give us an equilibrium constant that's equal to 1.5 times 10 to the minus 8. So you can see that this is quite a small equilibrium constant, and so we don't expect to get a very high concentration of ammonia or H2S in the gas phase. Now what happens if I decrease the volume on this vessel? So I push this little piston down and I decrease the volume in which these gas particles can exist. When I do that, I increase the pressure in this vessel. So if I stay at the same temperature, decreasing the volume of a gas increases its pressure. So now the molecules have less volume to roam in, and so their pressure increases, but their concentrations also increase because concentration is number of moles per unit volume, and if I've decreased the volume, then I've increased the number of molecules in a given volume. So I think you can see that if I decrease the volume or increase the pressure, that these concentrations or pressures will be larger than they were over here. If this system was at equilibrium and that product of concentrations was equal to 1.5 times 10 to the minus 8, then this system cannot be in equilibrium with the same amount of NH3 and H2S above the solid because the product of those new higher concentrations will be greater than the equilibrium constant. And so after we do this, we're ending up with a Q that is greater than our equilibrium constant. That means that we have to do something to reduce the value of Q, and the only way to do that is to reduce the concentrations or pressures of NH3 and H2S. So the reaction is going to go in reverse to use up the gas and form the solid. If we start with this system in equilibrium and we increase the volume or decrease the pressure by raising this piston, this lid, then the opposite will be true. So we will end up with a Q that is less than K, and then what will have to happen is some of the solid will have to break apart to form more gas to increase these pressures so that their product is equal to the value of K. So in general, if we increase the total pressure, then the reaction is going to try to counter that by using up that extra pressure, so the reaction will proceed in the direction where there is the least amount of gas. Conversely, if the total pressure is decreased, then the converse will happen. The reaction will proceed to the side with more gas. And that's the basic idea of the effect of total pressure on reactions that contain gases.